All right, hi everybody. Want to go over the information for today. Gonna try this a little bit different today. In the past, it was just a video, and it takes the videos a long time to download. But for some reason, if I share my screen with you, and there's still a video portion to that, it doesn't seem to take nearly as long to download these. So, a couple things, quite a few things actually I want to go over with you today. I want to start off with our warm-up question. The warm-up question for today was, how can, or what are two ways you can increase your momentum? Well, the new equation we learned is P equals M times V. Momentum equals mass times velocity. So an increase in your mass would increase your momentum, or an increase in your velocity would increase your momentum. The second thing we want to go over today are the review questions for section 2. It says, why would a dart player have to aim above the target? Well, gravity's pulling down on that dart, so the longer that dart's in the air, the more gravity is going to pull down on it. The harder you throw the dart, which means it's going to get there faster, the less it's going to drop. Which is why whenever you're shooting a gun or shooting a bow is a great example, you have different pins in your bow. So you aim higher the further away you are, so that arrow will drop in as it approaches the target. The closer you are, you don't have to aim as high because it's going to get there faster. The second question talks about the force. We talked about centripetal force in this one. The string is holding it from flying out. If you would cut that string, then obviously the yo-yo would fly out in whatever direction it was moving at the time the string was cut. The third one, does the mass of an astronaut change when he or she is in orbit around Earth? Mass is the amount of matter in an object, so no, that is not going to change. His weight change, absolutely, right? Weight is the force of gravity acting on him. So weight is determined by both mass and your distance. So the further you get away from Earth, you get out into space, where you don't have the effects of gravity of the Earth, you then are going to weigh less, but your mass would not change. The next section here is on orbital motion. Want to slide up my board here so we can brief that drew real big. I know that this is kind of off in the corner of your desk here. But if we are looking at the Earth and the Moon, how does the Moon orbit around the Earth? Well, the force of gravity is pulling it into the Earth. We said Newton's first law of motion, the object of motion will stay in motion, which will be traveling at this direction. But we take the vector of those two forces, right, and the Moon would move to this part. Now gravity is pulling it down. Newton's first law of motion has it going that direction. Again, the in between the two forces continues it orbiting around. Now, if it were speed up and this would be greater than this, it would slowly get further and further away and escape the Earth's orbit. If it would slow down, or the force of gravity would be greater, and gravity was greater than the force of the momentum that's going around the Earth, then it would get closer and closer and closer until it would crash into the Earth. So the key here is it's very hard to capture another object to get exactly at the right speed and have the exact force of gravity where they're going to balance each other. It's just going to continue to forever orbit around in a circle. Most times when something gets close enough to be affected by gravity, it either is going too fast that it spins away and escapes gravity, or it's going too slow that it crashes into the body that it is orbiting. That takes us to your third question. What purposes are artificial satellites used? We use artificial satellites for weather, telecommunications, many different uses with our satellites. And geostationary satellites, why are they used for communicating and monitoring weather? Right, as these satellites go around the Earth, and there are two different types of satellites that you may have learned about last year, Mr. McCullough's class. Some that orbit polar orbitals, so as they're orbiting around, the Earth spins below them. And we have other ones that just stay over a certain portion of the Earth all the time. So we're always getting weather data on Russia, China, the United States, wherever they happen to be orbiting over top of. That moves us to today's lesson. Moving along, it is about Newton's third law of motion. Newton's third law of motion says for every action force, there's an equal but opposite reaction force, which is where you can see the picture of the boy jumping off the boat. The action force is him pushing on the boat. The reaction force is the boat pushing back on him. If the boat were large enough, he would jump off the boat would move negligible, like a cruise ship. The cruise ship is so massive, it's not really going to move at all. With this little boat that he's jumping off of, when he pushes back on the boat is also moving. If it weighs less than him, it's going to move more than him, and he is not going to make it to shore. Another good example is the boy in the wheelchair pushing the basketball or the medicine ball. Again, F equals M times A. So the forces are equal, right? But because the mass of the boy is way larger than the mass of the ball will have a much greater acceleration than the boy will, because the forces, again, are going to be equal. The last thing I want to talk about, we have a lot of things that we're going over today, I know, but hopefully most of this is just a review. The new thing for today is momentum. P equals M times V. Momentum equals mass times velocity. What I am going to have you do, you're going to choose two NFL draftees. If you were watching the draft like I was this weekend, hopefully you saw some of the players that your team chose. If you don't care for the NFL or have a favorite team, you can just pick two random players. So you're going to choose two players. This is going to be your assignment for tonight. You're going to calculate the momentum based on their statistics at the NFL draft. So I'll give you the link to that. I'll attach them to the assignment here. Click on the link, choose your player. My player's not here. I am a Cowboys fan, so I'm going to go with CeeDee Lamb. Once you find the player you want, click on his name. It'll pop up. It'll give you his 40-yard dash time to help us calculate the velocity. It will also give you his mass right here. So CeeDee Lamb weighs 198 pounds. Here in the 40-yard dash in 4.5 seconds. The only minor problem we have with this is these units are both English and not in metric units. We need to do some conversions here. So the info first, mass is 198 pounds times 0.45. That's the conversion rate. You can Google that and look it up if you want to, or just trust me. So it's 198 times 0.45 gives you 89.1 kilograms. His time was 4.5 seconds. We don't need to convert that at all. The distance he ran was 40 yards. We want that to be in meters. So we take 40 times 0.91. Again, that's the conversion rate. You can Google that if you'd like to. And we get, he ran 36.4 meters. The equation we're going to use, P equals M times V. Well, the problem here, we have a mass. We don't have a velocity. Good thing we can calculate velocity. Velocity is distance divided by time. So our velocity, our distance was 36.4 meters. We calculated that right here. Our time right here was 4.5 seconds, or his time, I should say, which gave us a velocity of, and I didn't round that very well, I did it down below, of 8.1 meters per second. So now we have a velocity. P equals M times V. Take 89.1 kilograms, that's our mass, we already calculated that, times our velocity, we just calculated 8.1 meters per second, gives us a momentum of 721.7 kilogram meters per second. So that's my example. You can't use CeeDee Lamb even if you're a Cowboys fan. Choose somebody else. You can choose some of the other draft picks if you would like to. I don't care who you pick. Just choose any two players off that list and calculate their momentum. Attach that to the assignment for today. If you have questions, shoot me an email or join them for office hours. Hope everyone's having a great day. Talk to you guys soon.